Hello, and welcome to another Nature of Code vlogtorial thing. And I just want to reiterate, these are vlogs, so I'm not very good at any of this, so there will be a lot of mistakes. And of course, if you have any advice on how to do this correctly, I will welcome them with open arms. How about that? It's been a little while. I got a little scared with this episode because at the end of the last one, you remember I said there was a lot of math involved, and I got a little bit confused on how to handle this upcoming bit. Let's just get right into it. So, looking at the Nature of Code book, we're going to be going over, these normal distributions. And if you've read it already, or want to read it now, you might notice that I think in Java in general, I'm not sure if it's Java in general or processing, there's this next Gaussian thing that will generate a random number on a Gaussian normal distribution. But we don't have that in Hex, so we're going to have to make that. So, how do we make that? Well, with a little bit of Googling and research and looking up stuff, I went to Wikipedia, because, they have everything there. And I found this about normal distribution. There's this equation here. I don't know what it means, so I got a little bit confused. And then I think I looked around some more, and I think I forget how I found the next step, but essentially I found about Box-Mueller transformations, which reading this I actually kind of understood, which was nice. And then they even had some code here that we can steal. Use, borrow, adapt. Or something. It's in C++, and that's actually fairly close to Hex. But the thing about it is, I continued looking, and I looked at this next step, Marsaglia polar method. And I think this one made the most sense to me. And it even had some more code on how to do it. And it looked a bit simpler to use. And in the end, I think I tested out this version here. And it even takes in a mean and a standard deviation, much similar to what they do here in the book. So I figured maybe we'll do this one, the Marsaglia? Marsaglia? Yeah, I'm not sure how to pronounce that. So yes, let's take this code, or even this code, and drop it into Hex. So, yeah, let's do that. So if you want to take a look at this, just real quick, it's got a couple of variables that it's declaring, a double, which we'll use a float for that, which is a spare number that it'll keep in mind for the next time around, because it generates two numbers each time. And then a boolean about whether the spare number is ready or not. And then this will be a static function, and it'll, if there's a spare number, it'll shoot that back with a return. But if not, it'll go through this and make our two random numbers, and then send it back. So let's get to it. Okay. Um, do 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 do. All right, so we're back in Flash Develop. Things might be changed a little bit. I had to reinstall and do all sorts of weird stuff with Hexe and Flash Develop. But that's beside the point. Let's make some randomness on a normal distribution. Alright, so if we open up our project in source code, this is something that we might want to use in general. So let's make a new folder. I think I'm going to call it util, and inside here we're going to add our new class, and let's call it Gaussian, like that. Okay, so since we're going to be working with a static function, I don't think we need to use our new at all. So I think I can just take that out like that, and then we can just start porting over the code. So there is a private static float called spare, but we're gonna make that like that. And there's going to be a private static boolean called is spare ready. Oh, you know what I'm doing wrong? Yes, you do. I forgot a very important thing. A var a var variable. Okay. Sorry, I'm rusty yet again. It's been too long since I've been programming. But maybe that's educational. Anyways, so we're going to make a function that will, make our Gaussian number. So we'll make it a public static function called get Gaussian. That's what they're calling it. And it's going to take in the mean. That'll be a float. And it's going to take in a standard deviation, which will also take a float. Okay. And, I've never really done a static class like this before, so let's just do a quick test. So we're gonna trace something, and it's just gonna say Gaussian, because it's get Gaussian, so it's gonna give us Gaussian. So all right, so let's give it a quick test. No, we'll leave all that in there. So in the new, let's try this. It's in Gaussian. Oh wait, yes, Gaussian. We'll import that. Oh wait. Do I need to do this? Import Gaussian. Util Gaussian. Okay, good. So now I do Gaussian, get Gaussian, like that. When I run it, hopefully it'll say get Gaussian. But no, not enough arguments. Oh, okay, yeah. We have to send in our mean and float, even though it doesn't really do anything. Hey, and there it goes. It says Gaussian. Okay, so that seems to be working alright. I was a little afraid it wouldn't. But let's continue. So looking at, I'll just delete that. So looking at the code again, the first thing it does is check if the spare is ready. Is spare ready? And if it is, it will set isSpareReady to false and return the spare. But if the spare isn't ready, we're going to make it. So, let's see. First it makes a few doubles, but we are going to make those floats, so that's going to be var u float. Oops, I should close that. Var v float and var s float. And what it's going to do is it's going to pull up some random numbers. So it's going to do, I don't know if I talked about the do while loops much. I think I did a little bit. And so it's going to do this until it gets the correct kind of number. So u is going to equal, let's see, I think it's a math random times 2 minus 1. And then v is going to equal the same thing. So let's copy that over. And whoops, and change that to v. And s is going to equal u squared plus v squared. I think I can just do u plus u, u times u plus v times v. Like that. And we're going to do this while s is greater than or equal to 1, or s is equal to 0. Because if on the rare chance that we somehow get 0 in both of these numbers, I believe, later we have to divide by 0. Or we have to divide by this number, so if it's 0, we can't do that. So next we have a variable called mul that will equal the square root, math square root. And if you've looked at the code, you'll notice a lot of this stuff is essentially the same. So what I'm doing isn't I don't know if it's ethical really. I'm just copying the code, but that's kind of how it goes sometimes. So the square root of -2 times the log math.log s divided by s. Okay. So the spare I did something a little bit wrong, but I'll get to that in a second. And if you've been following along with the Wikipedia code, you'll see what my problem is. But anyways, so the spare equals v times mul Got a little ahead of myself there. And is spare ready will equal true. Otherwise, we will return the mean times mean plus the standard deviation times u times mul. So yes, what I forgot to do is it's returning all this times mul. So with spare up here, we need to multiply it by standard deviation. Oops. std dev plus the mean. And actually we could do this outside, but I don't know, maybe it's kind of cool just to put it all in there. Maybe not. Oh well. So, that should be everything. So let's give this a try. Let's save it up real quick. And now, let's trace our Gaussian times that. So what we're putting in here is the mean and the standard deviation. So essentially, from what I remember, the 4 times I took statistics class in college, and I wish that was completely a joke, but it's not. Anyways, the mean is sort of the center of the bell curve. So wherever we put that, it will sort of move it kind of left or right, technically, depending on how we use these numbers. So, and the standard deviation is kind of how wide this bell curve will be. So, let's do this. So for our mean, I guess we'll just put 1 for now. And our standard deviation, let's just put 1. So if I remember correctly, this should, well, let's run and see what it does. And actually, let's not put that in the new. Let's put that in our loop. We'll put that in update here. Right there. And run it and see what kind of numbers it prints out for us. So, it's going really fast, but I think we are getting, yeah, wish I could kind of see those. I think we're getting numbers somewhere between -2 point something and positive 2 point something. Let's see, what happens if I go to our project XML and bring the frames per second down to 3. Let's see what happens. Okay, that's a little bit easier to read. So yeah, it looks like our standard deviation is, oh, we even had a 3 in there, is somewhere between actually, you know what? Let's say our mean is 0, and see if we get more kind of regular looking numbers. Okay, we got a -2.1 something there, and a +2 there. Okay, so again, I'm not very good at math, but I think our numbers are somewhere between -pi and pi. Let's see what pops up here. Yeah, so, but it's kind of weighting towards the center, so it'll be very rare for us to get like a full -3 point. Oh wait, there's a 3.2, so maybe I'm completely wrong, but it was really rare. So But I think that is essentially what's going on. But don't take my word for it. If any of you guys know, please let me know, because my math is not good. But yes, if you notice, most of them, it's kind of trending towards a 0 point something something. So let's recreate what they have here, where it's kind of randomly placing these circles like that. So let's drop in our draw method how should we do this? How should we do this? Yeah, I think just inside of our draw, we'll say this graphics begin fill, and let's say our color is, let's see, we're on an orangish background. We have something that's already kind of green, something that's already kind of blue. Let's go kind of pinkish, purplish, something like that. How about that? Really dark purple. And then we'll give it an alpha of, let's say, 2.5, quarter opacity. And then what we're going to do is we are going to, and actually I think I saw that we don't really need the this in this case, but we'll do it anyway. This graphics, draw a circle, and we are going to put it at, let's see, Gaussian, get Gaussian. Let's see, our mean will be the middle of the stage. So let's see, let's look at our project XML again. Where is that? Oh, it's highlighted. I'm an idiot. Anyways, yeah, let's set this back to 30. And actually, yeah, so our width is 640. So X will be 320. Oh wait, am I doing that right? Yes, will be 320 with the standard deviation, which I think is kind of the width, but divided by 3. Let's just kind of guess it and say 100, I think. Let's try it. 100. And then our whoops, I need to close it out again. No, that's right. Gaussian, get Gaussian. Okay. And then our Y position will be along the same line. So we will just put that in the middle. So height is 360. So that's 150, 180. 180. And the radius, oh, you know what? I forgot to say what kind of thing is being returned from the get Gaussian. It'll be a, yeah, it says void there, but it should be a float coming out. But anyways, in this we need a radius for our circle. Let's make it 25. So yeah, let's look at our Gaussian, and our get Gaussian is going to return a float. And let's save, and then let's save everything and run it and see what happens. Oh, yeah, it's jumping left and right, but since it's clearing, we're not really getting to see how it stacks up. So let's get rid of our biased walker and random counts, and let's also get rid of how they draw, and I think we're not doing draw array. Oh, get rid of draw array, and let's not clear either, and then run it and see what happens. Okay. Yeah, that's looking about right. So let's make our circle a little bit smaller. Let's go 16. And let's bring the standard deviation down to 50. No, let's do 75. And see what that looks like. Oh yeah, and let's turn off the trace. We don't really need that. Trace was in update, wasn't it? Yep. Yeah. You can see it's kind of grouping around the center, and very rarely it kind of pops out to the side. So I think this is essentially let's compare. Where is it? Scroll down a bit. Okay, and let's widen it. Ugh. And let's reset it. Yeah, it kind of looks the same. Maybe it's a little weird, but maybe that's just the way the randomness happened to go. Yeah, it looks a little lopsided. But yeah, that might just have been the way the numbers fell. But yeah. Yeah, let's run it one more time. Instead of 25 transparency, let's go to 10 and run it. Yeah, it's looking pretty good, I think. Yeah, there we go. Our Marsaglia random, not random, well, yeah, random, but normally distributed random distribution. Wait. You know what I mean. It's late. And I think we are successful. So, yes, thank you very much for this episode. Or wait, for watching this episode. And I hope to get the next one up soon. And if not soon, next weekend. And I just would like to say thanks for, I got a bit of Twitter action recently, and I think I have a couple new subscribers. So welcome, and yes, please let me know if there's anything weird about my videos. All input is welcome, except non-constructive input. You can keep that to yourself. But yes, that's it for this episode. And I will see you next time, where I think we will talk about Perlin noise, which I'm very scared because I could not find anything that I could really understand. So if anyone out there knows of an easy to digest version of what Perlin noise is exactly, or simplex noise, it was another similar method out there, please let me know. I would like to know. So, alright, until next time, bye bye.